Turns out there's other challenges we have when we're developing on iOS. For example, there is now a variety of different screen sizes that have to be supported. We've got the 3.5 inch over on the left, and then we've got the iPhone 5, and now we've got iPhone 6 in 2 additional sizes, as well as the iPad. So now we've got 5 different screen sizes potentially out there that we have to accommodate. Now developing on Android has always had this problem because the Android stack is developed by Google and there are many device OEMs that are building devices. Up until recently on iOS, there was a really small number of screens to support, really just the original iPhone and the iPad. Well, now we've got a little bit more, and of course with Apple Watch and who knows what products in the future, Apple's clearly moving to a layout mechanism that allows us to take into account different size screens. So the way we've done this in the past, it really depends. But for handling iPhones and iPod Touch screen sizes, normally we can deal with this using auto layout, as well as the legacy springs and struts based auto sizing approach that Apple originally supported. On the iPad, however, we've got quite a bit more screen real estate here. And so normally what we'll end up with when we're trying to do a universal app and supporting iPhone, iPod Touch, as well as iPad, we'll typically have a completely different layout in a separate storyboard file for the iPad. And even though we do that, we can still reuse a significant amount of our view controller code if we do that intelligently. So auto layout was introduced in iOS 6 and it replaces the legacy springs and struts based auto sizing. You might still run into the legacy approach if you're using various open source Cocoa controls and other components you're finding on the internet. But if you're writing your own application, a new application from scratch, you're obviously going to use auto layout. You're not going to want to use the legacy approach. So the whole idea here with auto layout is that we're going to build relationships among the views and specifying how the views, the peer views as well as their super views are actually related to each other from a layout perspective. Now the technology underlying auto layout was actually a constraint solving toolkit that was developed out at the University of Washington. And what it does is it uses the constraints to generate systems of equations, and it solves those automatically based on the equations that are generated. And so the constraints themselves are just rules that specify how one view's layout is limited with respect to another. And these constraints can either be requirements or preferences. Now auto layout originally had kind of a reputation for being hard to use, and perhaps the fact that somebody's written an entire book on just this topic might be evidence of that. But in reality, it's not really that bad, and it does give you significant flexibility in how you do your layouts, much more flexible than the legacy mechanism that was there initially. And the beauty of it is the way Apple designed it into the SDK is you can adopt it incrementally. So you can kind of mix and match. You can use this springs and struts on some controllers, auto layout on the others. So you can kind of control it, turn it off and on at a controller basis. Nowadays when you create a new project, I believe it's on by default. But if you ever want to turn it either on or off, if you just select the view controller and interface builder and then open up the file inspector over on the right side there, and under the interface builder document section, which is the first tab, you'll see a checkbox down under the interface builder document settings that says use auto layout. So you can turn it on and off right down there. So using auto layout, we can express the constraints either in Objective-C or Swift code, or we can also establish the constraints visually using Interface Builder. And this second approach is kind of convenient because Interface Builder will intelligently detect or suggest missing constraints, and it comes up with all kinds of warnings and even error messages when we do things wrong. So tonight we're going to focus on this second approach. We're going to be looking at how to set up these constraints in Interface Builder. So what are these constraints like? Well, they let us do things like the examples I've got listed here. So we can match one view's size to another view's size so that they're always the same width. So if one of the view's width changes, the other will change accordingly. We can center a view or even a group of views within a super view. And so if you resize that super view, whatever those views are, they're going to stay right in the center. We could align the bottoms of several views. We could tie the top of one view to the bottom of another, so if one of them moves, the other one will move with it. And we can do things like prevent images from shrinking beyond a certain size. In terms of rule of thumb, when you're laying things out in Interface Builder and you're going to add the constraints in Interface Builder, always use these snapping guidelines when doing your layouts. For example, over on the screenshot on the right, you can see that I'm centering a button right in the middle of the view and I see those crosshairs. And so you want to kind of drop it right in the middle, and that signals your intent to Interface Builder that you do mean to center this thing vertically and horizontally. Similarly, when you're moving things up against the edge of the super view or even next to another peer view within a super view, make sure you always use the default or standard spacing. And you can tell when you have that setting, because when you move something close to another thing, you'll actually see the little dotted blue lines show up. Beware of any rules with magic numbers in them. So if you find yourself manually setting these numbers to arbitrary values, you might be violating some of Apple's user interface guidelines, or you might be doing something wrong. Not always, but just pay attention. And then as you're adding constraints and working on your interface layout, always make sure that you clear up any types of warnings or errors that Interface Builder tells you about before attempting to run. If you do have inconsistencies in your constraints, it could very well cause your program to crash. And when it does crash, you're going to get some rather cryptic output on the debug console. And believe it or not, once you get your mind around that output, it'll actually help you figure out which of the controls are involved in the problem within your Interface Builder layout. So when you do crash because of invalid constraints, make sure you keep an eye on that debug log. As you get better at understanding that output, it's going to be very useful in finding what the problem is. So in the next video, we're going to go back to our stopwatch app that we worked on several lectures back, and we're going to add auto layout to it so that it looks great on any size device in any device orientation. So no matter if it's in portrait or landscape, it's going to look great. So take a look at the next video.